This video is entitled Entities and goes along with Chapter 2 of the book Introduction to Database Systems Modeling and Administration, and I'm Dr. Reneau. I'll be taking you through this video. So the first question we want to ask ourselves in this chapter is, what is an entity? An entity are the things that we model. For instance, if we were modeling our DVD collection, if any of us still have a DVD collection, we would have an entity representing the DVD itself with its title. We would have another entity with the actor that was on the movie. We would have another entity that maybe was the director, or another entity that was the studio. In a conceptual data model, the way that I want us to draw the conceptual data model, um, it's a rectangle with little rounded edges around the outside, with the name of the entity in the middle. Examples: actions, events, people, items. Let's think of a retail store. A customer would be an entity. The item we're selling would be an entity. The store would be an entity, especially if we had multiple stores. An order would be an entity. Um, so we can see kind of what entities are, and we'll see a lot of entities as we go through this presentation. So entities fall into four main categories, and the categories are categorical, resource, event transaction, and event transaction detail. Let's go back to that store and talk about, let's go back to an imaginary small brick and mortar store where you sell, I don't know, stuff, auto parts maybe, or whatever. Um, the categorical tables, the categorical entries would be, well, what kind of part is this? Well, it's a filter, it's a bearing, it's a oil, it's those kinds of things. The categories that the items, or the categories that the customers, are the customers a business, or is it an individual, or is it a nonprofit, or is it a government? Those are things that we might want to categorize other entities into. The resource entities then are the actual entities where we store the part. The filter number, the filter description, that type of stuff. The customer number, the customer name, the customer's address, that kind of stuff. We would also then store the categories that the customer would fall under, like the category is a business customer, that would connect back into the category entity. We then have events slash transactions, or that's an or. An event would be a customer placing an order, or us receiving inventory from our vendors, or stuff like that. The transaction detail then would be if we received an order, or we received a shipment from our supplier of 30 different kinds of filters, 30 different filter numbers. There would be one entry in the event of the order coming in, of the receipt coming in, and then in the transaction detail table, or transaction detail entity, there would be a line for each of the filters that we got. Stop and think of an order that you did at the grocery store recently. You had an event. The event was your order, and then each of the things you bought on the order are the detail of that event transaction. So here are some examples of categorical entities that we may want to use. And again, remember, they're used to group other data entities, other data elements together. They rarely change. They're usually categories in a report, or on a report, or the ways that we break summaries of a report. Examples for a human would be their gender, or the language they speak. Or if we had a restaurant, the category of menu item. Is this an appetizer, a main dish, a dessert after? Is it a movie, what is the movie genre? Is it a sci-fi movie, or is it a romance, or is it a western? And even things like shirt. Shirts would have shirt sizes and color and other categorical data entities that go along with the shirt or the other entity that these categorical entities describe. So I spoke shortly about or briefly about resource entities. Let's look at what some example resource entities. Resource data represents data that events happen to. Things that events happen to. A customer buys something, an item is received or sold. um, Someone is an employee is hired, fired, gets a paycheck. Those are all kinds of events that happen, or transactions that happen to an entity. So these resource data is slow changing, but it changes occasionally. Maybe a student, if you had a student database where student was the resource entity with the category of sophomore, junior, senior, major, code, those types of things. The resource data entities can change. You can change your major, you can change your name, you can change things, but they don't change very rapidly. Examples include customers, vendors, locations. For instance, if we had a warehouse where we stored items in various locations in the warehouse, those locations would be resource data because they would be tied to the transaction of receiving, moving, or selling items from the warehouse, and inventory items. So we can see those are resource data entities. Here, for instance, is a resource entity that I'm going to use in my conceptual model that represents companies that we deal with. So you can see the data over here of the kind of spreadsheet of the company ID, their description, their taxpayer identification number on this side, and then over here you can see the object relation model, conceptual model symbol for the company. Again, notice it doesn't have any data. Yeah, that one over there. That one over there. Right. That one doesn't have any data. It just has the name of the entity and the bar around it and the box around it, showing that it's a conceptual entity that we're going to be modeling in our system. So, event transactions. Events are temporal. For most systems, an event is related to a moment of time or something in nature. Event data is created and collected when something happens. A new sales order, a meeting is scheduled, a package is received or delivered, a general ledger entry is posted, someone is hired, someone is fired, customer makes an order. All of those kinds of things would be an event transaction that creates an event transaction entity. Here's a table of event data that we would be collecting about general ledger entries. So there's a transaction ID, and in this example, I'm using a universally unique ID or a UUID. There's the transaction date and time of when the transaction happened. There's the company the transaction happened on, and then the description of what the transaction was. If you think back to your accounting class, hopefully you have had one at this point, you know that with the transaction come the detail of which of the ledger accounts are being affected. You'll see that in just a moment. So even though the data table is complex, the model representation is very simple, just the rounded rectangle with the name of the entity, and this transaction entity is called ledger transaction. Now, with that big transaction comes a lot of detail. Each of the ledger accounts that are debited and credited and the amount that they're debited and credited make the data detail that go with that master event transaction entity. Lots of detail, small. You can summarize those to make totals and balances, items and quantities on an order, items and quantities on a purchase order, something we're receiving, debits and credits on a general ledger entry. There are just so many of these detailed data. You'll see lots and lots of them as we go through this book in this semester. Here's an example of ledger transaction detail data, and you can see that there's a transaction ID that goes back to the transaction. Notice that all of these have the same transaction UUIDs, so these are detail that go with that one transaction. Actually, yeah, this is detail that all goes with that one transaction. You can then see the account ID number, account number 100, account number 300, and then you can see the amount that was debited and credited to those accounts in this transaction. Even though there are a lot of bits of information in the detail, we're not worrying about that at this point. We're not modeling the attributes. We're not modeling that. We're just modeling the entity itself, and you see it there with the rounded rectangle, and this is in object relation model notation of the name of the entity. I do like naming a detail entity that's related to a transaction with the name of the transaction detail with the word detail or something like that. So make these names meaningful, because the more meaningful the names are, the more valuable the picture is and the model is. It's easier to just look at, glance, read, understand, and know what they mean and know what they are. There's one last term I want to cover in this chapter, and that is the idea of metadata. Metadata is defined as data about data. So when we're creating these entity shapes, these represent data, the shape, the name, but they represent something else. It's data about data. We use metadata for clarity by adding meaningful names that follow the business rules and standard kind of understanding in the language you're using, usually English, in the context of this video and this book at this point. Also, metadata makes sure that we're accurate, because if we all have the same data about data and we all agree about the same data about data, then we're complete. We can communicate, and we can keep things understood. I'll use that term off and on through the book and through the rest of these videos, but I wanted to just let you know that metadata is data about data, and entities are data about data. We don't actually have the data in there. We're talking about data about the data. We're at a much higher level. Thank you for watching this video on Chapter 2 of the book Introduction to Database Systems Modeling and Administration. Again, I'm Dr. Reneau. I'm glad you were here, and I hope to see you in a future video. Oh, and if you're watching this on YouTube, like the video, pretty please, and follow if you will.